Hi everyone. In this lecture we're going to begin our discussion on the network layer, which is covered in Chapter 4 of your textbook. First, we're going to take a brief overview of the network layer and how it can be divided into two logical functional areas, the control plane and the data plane. In this chapter, we'll focus more on the data plane. In Chapter 5 next week, we'll look at the control plane. As we will see, the control plane relates to the routing function, and the data plane relates to the forwarding function. This will be followed by a short discussion of how a router works. Then we're going to look at the format, structure, and implementation of the Internet Protocol version of the network layer. And finally, we'll look at how the function of a router can be split between a local implementation component and a remotely controlled component using software-defined networking. We'll do this in 7 video lectures. In this first chapter video, we'll get a high-level overview of how the network layer works. The function of the network layer is to transport segments from one host to another. By segments here, I mean transport layer segments. In this diagram, the sending host is running an application that communicates with the receiving host over the Internet. The data starts from the application layer, where this data is encapsulated by a transport layer header. The host network layer software takes the transport layer segments and encapsulates them into IP datagrams, which are also referred to as packets. Note that I will generally use the term packets. Data link headers and trailers are added to the packets, and the resulting encapsulated message is sent out to the local area network via the physical layer. When the sending host and receiving hosts are on different networks, this message must go through a router which passes the message back up from the physical layer to the data link layer to the network layer. To get to the receiving host, the message passes through a series of routers which examine the network layer header fields in the IP packets passing through them and send the message on to the receiving host. At the receiving host, the message is received at the physical layer. The message is extracted by passing it up from this layer all the way to the application layer, de-encapsulating at each layer along the way. Note that in our discussion so far about the application and transport layers, we have only been interested in the end host. In contrast, all routers run at the network layer, and classically, they do not run at the application and transport layer. I say classically because nowadays, routers do run applications such as VPNs and firewalls. Also note that all hosts and routers do run the network layer and the layers below them, the link layer and the physical layer. The network layer has two functions, forwarding and routing. Forwarding is the process of moving a packet from the router's input to the appropriate router output. Routing is the process of determining a route between the source host and the destination host. Even though these are different processes, routing and forwarding are deeply related. Routing determines the end-to-end path, while forwarding determines the local forwarding decisions at the individual routers along the path. Let's look at an analog of these processes. Say you want to go from Boston to San Francisco and you're planning a road trip. The process of determining what roads you're going to take on this trip is routing. For example, you could start from Boston, then go to DC, then to Atlanta, then go to Dallas, continue on to Phoenix, and finally end up in San Francisco. But forwarding is the process of just getting through a single interchange. For example, going through DC, entering that city on the highway from Boston, and exiting that city on the highway to Atlanta. Let's consider the simplified diagram of a network with routers. Looking at the first router on the slide, it has 3 outgoing interfaces numbered 1, 2, and 3. The other routers also have their own interfaces. Now, a packet arriving at this router could go out any of these 3 interfaces. The routing algorithm determines what interface the packet should use to exit the router. This will have been determined by the best route to the packet's final destination. The routing algorithm has populated a forwarding table, which tells the router where to send this packet. Let's look more closely at this forwarding table. If the packet has an IP address of 1001, the router is going to send the packets to the output interface 1. If the packet has an IP address that equals 0101 or 0111, the router is going to send the packet to the output interface 2. To reiterate the important interplay between routing and forwarding, routing determines the end-to-end path, while forwarding determines the local forwarding decisions at the intermediate routers. As I mentioned before, the network layer can be split into two functions. The data plane does the forwarding function, determining how to get a packet from the input port to the output port. This is a local function performed by every router. The control plane provides the routing function. This function is network-wide because routers must communicate and cooperate to determine the end-to-end path from source to destination. Classically, the control plane has been implemented in each router. A more recent approach has been to implement the control plane in remote servers using software-defined networking, SDN. The next two slides illustrate this. In the classical routing, the routing algorithms are run on each router. Routers interact with each other to determine the end-to-end path. In contrast, with SDN, there's a centralized controller that runs the routing algorithms. This controller communicates its decision to the individual routers in its area of control. These routers use this information to make the forwarding decisions. We will discuss SDN in more detail in the last video of this chapter and in a Chapter 5 video next week. In the next video, we'll discuss the internal components and basic operations of a router.